Bismillahirrahmanirrahim. Student, how are you? I hope so you will be well. Now today we are just going to start the previous chapter, chapter number 14. And in chapter number 14, we are just going to discuss about the new topic. The first one we can say that is the refractive index of light, and second one the numericals. Now, first of all, we are just going to say that what do you think about the refractive index of light? So, you know very well, in the previous one, you will study that refraction means the bending of light. When the light passes through the rare medium to the denser medium, then it is just going to be bent. But what is the situation? What are the causes or what is the reason? Because that is due to, we can say, the first one is the medium, and second one, due to the medium, the speed of light is just going to be changed. So, according to the refractive index, we can say the ratio of the speed of light in a vacuum to its speed in a specific medium. Refractive index, we can say the ratio of the speed of light in a vacuum to its speed in a specific medium. So, if we observe that the refractive index of water is 1.333, meaning that light travels 1.333 times slower in water than in a vacuum. Increasing the refractive index corresponds to decreasing the speed of light in the material. Mean, we can say whenever the speed of light coming from the real medium, then it will be increased. But when it is entered into the denser medium, then its speed will be decreased, mean it is come into slower. So that's why we can say that the refractive index determines how much the path of light is bent. How much path of the light is bent, or we can say that is the refracted when entering a material. So it is described by a physicist, Snell's law of refraction. It is described by Snell's law of refraction. So he said that refractive index that is represented by the small n is the ratio of the speed of light in air and the speed of light in medium. What is the refractive index? Refractive index, we can say that is the ratio between the speed of light in air and the speed of light in medium. Or in other words, we can say the sine angle I upon sine angle R. So, what do you think about the sine? In the trigonometric ratio, sine is said to be the ratios. So, again, I'm repeating the formula for the refractive index. Refractive index is equal to small n, and that is equal to the speed of light in air upon the speed of light in medium. Or also it can be sine angle I upon sine angle R. I hope, Susan, you will understand the refractive index by their formulae. Now, we are going to solve the numerical. Three basic numerical is just going to relate with the refractive index. So, keep in your mind these two formulas so that you can solve the numerical very easily. So, now we are going to say the next one. Number of numerical is 14.1, and its option is calculate speed of light in glycerine if its index of refraction is 1.47. Now here we have to calculate speed of light in glycerine if its index of refraction is 1.47. You know very well the speed of light in air or in vacuum is a constant. That is, we can say it is 3 multiplied by 10 raised to the power 8 meter per second. But here we have to calculate the speed of light in glycerine because the medium of glycerin is different as compared to the vacuum because vacuum is having the no medium while glycerin having the medium and it is the denser as compared to the air. So to solve the numerical, first we make up the data and in data it is based on the three things. The first one is the given, second one is required and the third one is the solution. So now we are making their data in given. We know very well the speed of light in air is equal to 3 multiplied by 10 raised to the power 8 meter per second, while refractive index that is equal to n and that is equal to 1.47. Now in required we are going to find out the speed of light in glycerine. So on the next step, we will use the formula which is just related with the refractive index. So N, you know very well, represented by the refractive index. So refractive index is equal to speed of light in air divided by speed of light in glycerine. So here, the next step, we have to find out the speed of light in glycerine, not to be the refractive index. That's why we are just going to change their position. So here, speed of light in glycerine is denominator, or we can say is in division. So after shifting, it will come in multiplication, and as well as and is in multiplication, so after shifting it will come in division. So we can say speed of light in glycerine is equal to speed of light in air divided by refractive index. Now after that we are computing their value. So speed of light in glycerine is equal to 3 multiplied by 10 raised to the power 8. It is the speed of light in air and divided by refractive index of glycerine. So 1.47 is the refractive index of glycerine. Now to simplify it, we will divide 3 with 1.47. Then we are getting 2.04 multiplied by 10 raised to the power 8 meter per second. Meter per second is the unit of speed in System International. So what will be their result? Their result will be, we can say, speed of light in glycerine is equal to 2.04 multiplied by 10 raised to the power 8 meter per second. I hope so, student, you will understand 14.1 numerical. Now we are going to solve the another one. Another numerical is stated that the speed of light in water is 2.25 multiplied by 10 raised to the power 5 kilometer per second. And here, what is the index of refraction of water? What is the index of refraction of water? In the previous one, index of refraction is given and we was finding the speed of light in glycerine, or we can say in another medium. But here the difference is that we have to find out the refractive index of water while its speed is given. So we are making their data and given we having a speed of light in water is 2.25 multiplied by 10 raised to the power 5 kilometer per second. But in the previous one, we learned that the unit should be relate with the SI system. But if we observe that speed of light unit is in meter per second, but here kilometer is given. So we are just going to remove kilometer. So we know very well 1 kilometer is equal to how many meter? So we know that 1 kilometer is equal to 10 raised to the power 3 meter. So on the next step, we will just replace kilometer and computing their value, that is 10 raised to the power 3 meter per second. So we can say that the speed of light in water is equal to 2.25 multiplied by 10 raised to the power 5 multiplied by 10 raised to the power 3 meter per second. After that, we will calculate it. In mathematics, we know very well in multiplication, when the bases are similar, then power will be added. So here base is 10, here base is 10. So both are similar. So we will just add their power. So here power is 5 and here power is 3. So it will become 8. So on the next step, we will write 2.25 multiplied by 10 raised to the power 8 meter per second. Now we will write the another given, that is speed of light in air is equal to 3 multiplied by 10 raised to the power 8 meter per second. Now in required, we have to find out index of refraction of water, that is represented by N, and it is a question mark. Now, in solution, first we will write for index of refraction of water, that is equal to N, the question mark. Now here we will use the same formula which we have learned in the beginning of this lecture. So index of refraction of water is equal to N, that is equal to speed of light in air. Index of refraction of water is equal to N is equal to speed of light in air divided by speed of light in water. So here index of refraction of water is equal to N. After that, computing the value of speed of light in air, that is 3 multiplied by 10 raised to the power 8, while computing the value of speed of light in water, that is 2.25 multiplied by 10 raised to the power 8. So look here, in simplification, 10 raised to the power 8 is given and 10 raised to the power 8 is given. So both are similar, then we will cancel it. So we just having 3 divided by 2.25. So we will divide 3 with 2.25, then we will get 1.33. So we can say 1.33 is the refractive index of water. So index of refraction of water is equal to N, that is equal to 1.33, or in other words we can say this is the refractive index of water. So the next numerical we having 14.3. So here little bit change according to the previous one, but the formula is similar. Mean like light travels from air into water whose index of refraction is 1.33. In question, it is saying that light travels from air into water whose index of refraction is 1.33. If the angle of incidence is 40 degree, what is the angle of refraction? So here, on the previous one, we learned about the speed of light, but here angle is given. So according to the Snell's law, it is also equal to sine angle I upon sine angle R. So here we will use like that formula. Now, in given, we having index of refraction of water is equal to N, that is equal to 1.33. This is the index of refraction of water, that is equal to n, and that is equal to 1.33. After that, we will write the angle of incidence that is equal to angle I, and that is equal to 40 degree. Now, here required is angle of refraction, and angle of refraction is represented by angle R. This is a question. Now here in solution, first of all, we will write uh, the required is for angle of refraction that is equal to angle R in question mark. And here we can say that in formula, index of refraction is equal to n, that is equal to sine angle I upon sine angle R. It is another formula for finding the index of refraction when angle is given. So n is equal to sine angle I upon sine angle R. So to find the value of angle R, so we will reshift their positions. So sine angle R will shift on left hand side. So it will come in multiplication, while n will shift from left to right and come into the division because it is in the multiplication. So after shifting, it will come in division. But one thing is most important is that here sine is not required. The value of sine is not required. Here we have to just find out the angle R. So we will shift sine from left to right. So first it will come in division. After that, we will shift in the numerator. So what will be happen? Its sign will be changed. If it is in positive, so convert into negative, and if it is negative, so convert into the positive. That's why this sign will come in sine inverse. It is also said that sine inverse. Now, we will computing their value. Sine will remain same. Angle I is 40 degree, while N means refractive index of water is 1.33. So, before going to simplify it, first of all, we know what is the value of sine 40 degree. First, we will find out the value of sine 40 degree. With the help of calculator, uh, we are getting sine 40 degree is equal to 0.642, and 0.642 will divide by 1.33. So we will get 0.483. So this is the angle R is equal to sine inverse 0.483. Mean this is not the angle. So from this position, we will go to find out their angle. So with the help of the scientific calculator, we can find out the angle. How we can use or how we will find out? So first, you will on the scientific calculator, then press a button in which shift is written or a second is written. After that, press the button sign. Then on the display, you will find out sine inverse. Then you will write this value 0.483. Then press button equal. So you will get their value, and that value will be equal to 28.90. So this 28.90 is showing the angle, and this is representing to the angle up. So here angle of reflection will be equal to 28.90 degree. Now We are going to solve the next numerical, that is the 14.4, and the question is the focal length of a convex lens is 10 centimeter. Focal length of a convex lens is 10 centimeter. Where should an object be placed to get a real image? Where should an object be placed to get a real image? And the second one, a virtual image. Twice the size of the object. Mean here, in the data, we will make their given. The first one, focal length is given. The focal length is represented by the small f, that is equal to 10 centimeter, while one thing is given more. Image twice the size of the object. Twice the size of the object, basically it is showing the magnification. So we can say magnification is represented by the capital M, and that is equal to 2 times. 2 times means that is the, we can say it is bigger or larger as compared to their size of the object. Now, in required, we are going to determine object distance, that is a small p, and here we will write image is real. If the image is real, then the q will be in positive, while on the second way, object distance, again we have to find, but here image is virtual. So why we are writing the image is virtual? Because q is in negative. Again, I am telling you that just observe here, q is present. So you will say no. That's why when we are going to use the lens formula, first we have to find out the value of q. So in solution, first of all, we are going to find out uh, image distance. And image distance is represented by the small q. So here we will use magnification formula, and this formula we can say m is equal to q upon p, mean the ratio between the size of the image and the size of the object is set with the magnification. Here we will compute the value of magnification, that is 2. Q and P will remain same. But to find the or to make the Q as an object, then we will shift P on the other side. So it will become Q is equal to 2P, because here P is in division. After shifting, it will come in multiplication. So 2 will multiply with P. Now, student, we are going to find out the next way for the object distance when the image is real. Now we are going to find out the object distance when the image is real. So here we will use lens formula, that is 1 over f is equal to 1 over p plus 1 over q. So we are going to compute their value. F is 10, then it will become 1 over 10 is equal to 1 upon p will remain same, because we are going to find out the value of p, as well as here 1 upon q. At the place of q, we will write 2p, because previous one we find out the value of q, that is the 2p. But here this 2p will be in positive because image is real. So after that, we will take their LCM of the denominator. Here is p and here is 2p. So the LCM of p and 2p we are getting, that is the 2p. So after that, we will compare LCM with the denominator of the each fraction. If it is not equal, then we will try to equalize it. Let's see here. The denominator of the first fraction is p, but LCM is 2p. So it is not going to match. So we have to equalize it, then this p will multiply by 2. If we are multiplying 2 with p, then we must have to multiply with the numerator. So numerator is 1. So 2 1 is a 2 and 2p is a 2p. After that, we will compare the denominator of the second fraction. Here is 2p and the LCM is 2p. So both are similar. So we will just write their numerator as it is. The numerator is 1. After that, we will simplify it. 2 will add with 1. Then 2 plus 1 equal to 3. So 1 upon 10 is equal to 3 upon 2p. After that, we will cross multiply it. Then 2p will multiply 1. Then 2p 1 is 2p. Then 10 will multiply with the 3. Then we can say 10 multiplied by 3. After that, 10 3s are 30. Here we want the value of p, but here 2p is given. So we will shift 2 from left to right. So it will come in division. After that, we will divide 30 with 2. We will divide 30 with 2. Then we got 15 because 2 ones are 2, 2 15s are 30. So object distance is 15 centimeter if image is real. Now we are going to calculate for object distance P when the image is virtual. If the image is virtual, then the value of Q will be in negative. So here we are also using the lens formula, that is 1 over F is equal to 1 over P plus 1 over Q. Now here we are computing their value. Then focal length will remain same, that is 1 over 10 is equal to 1 over P will remain same, and 1 over Q, the value of Q will be changed because here image is virtual, that's why we are writing minus 2P. On the next step, first we will multiply their sign. So minus multiply by plus, plus minus minus. So it will become 1 over 10 is equal to 1 over P minus 1 over 2P. After that, we will take the LCM. You know very well, the LCM will come 2P. After that, we will compare their denominator with the LCM. Here is P, here is 2P. So we will multiply 2 with denominator and numerator as it is. So 2 ones are 2, we are getting minus as it is. 2P, 2P similar, then we will write 1 as it is. Now 1 over 10 is equal to 2 minus 1, that is equal to 1. So it will become 1 over 10 is equal to 1 over 2p. After that, we will cross multiply it. 2p, 1 is 2p, then 10 multiplied by 1, 10 ones are 10. To find the value of p, we will shift 2 from left to right. It will come in division. So 10 will divided by 2. Then what we will get? 2 5s are 10. So the answer will come 5 centimeter. So here we can say if the image is virtual, then the object distance will be equal to 5 centimeter. I hope so, student, you will understand this numerical. Now we are going to find out the next value from numerical 14.5. Now question is that find the focal length of a convex lens. Now here we will find out the focal length of the convex lens while object distance is 5 centimeter, image distance is 10 centimeter, and the image is virtual. And the second one is P is equal to 30 centimeter and the image is real. So here we will make up the data. First we will write object distance is equal to P, that is equal to 5 centimeter, and image distance is equal to Q, that is equal to 10 centimeter. So here we are writing image is virtual. And the second one, we will write object distance is P, that is equal to 30 centimeter, while image distance is Q is equal to 10 centimeter, but image is real. So you are looking at here object distance is changed. In the first one, object distance is 5, and the second one, the object distance is the 13. Now, in required, we will find focal length. In B, we will also find out the focal length and check out what will be happen when we are going to change their object distance. So here for finding the F, we are using the lens formula 1 over F is equal to 1 over P plus 1 over Q. That is also equal to, by computing their value, 1 over F is equal to 1 over 5 plus 1 over minus F. Why I am writing minus because image is virtual. If the image is virtual, then the Q will be in negative. Now, after that, we will multiply this minus with plus sign, then we are getting 5. So, 1 over f is equal to 1 over 5 minus 1 over 10. After that, we will, on the next step, we will take the LCM of the denominator, 5 and 10, we are getting 10. So, we will multiply 5 with 2 so that it will equal to the LCM. So, 5 to the 10, so 2 ones are 2 minus 1, because this one writing as similar because their denominator are similar with the LCM. Now here 1 over f is equal to 2 minus 1 equal to 1, then upon 10. After that we will cross multiply it, then we got the uh, f is equal to 10 centimeter. Now we are going to find out again focal length when the image is real. So again, using the length formula, that is 1 over f is equal to 1 over p plus 1 over q. So we can say that 1 over f is equal to 1 over 30 plus 1 over 10. Here q is in positive because image is real. After that, we will take the LCM of 30 and 10. Then we got 30. This 30 matching with the LCM, then we are writing the numerator as it is. But on the next fraction, denominator is 10 while LCM is 30. So we will match it. Then 10 will multiply by 3 and 1 will multiply by 3. 10 3 is 30 and 3 ones are 3. Then on the next step, we will write 1 over f is equal to 1 plus 3, that is equal to 4. 1 over f is equal to 4 upon 30. Now, on the next step, we will simplify it. 2 to the 4, 2 15 the 30. After that, we are just going to take their reciprocal to find the value of f. Then it will become f only and it will become 15 upon 2. So its value will come 7.5 centimeter. When we will divide 15 with 2, then we will get 7.5 centimeter. I hope so. You will, student, you will understand this numerical. Now we are going to solve the next, that is the 14.6. So here we just have to find out the focal length of a convex lens is 1 meter and an object is placed at a distance of 2 meter before it. Determine the position, nature, and magnification of the image. So here in given focal length f is equal to 1 meter, object distance is equal to p is equal to 2 meter, and in required, first we have to find the image distance q, then find the nature of the image, and the third one we have to find the magnification. Here we will also use the mirror formula for finding the image distance q. So 1 over f is equal to 1 over p plus 1 over q. To find the 1 over q, we will shift 1 over p on the other side. So it will come in negation. So we can say 1 over q is equal to 1 over f minus 1 upon p. After that, we are computing their value 1 over 1 because f is 1 minus 1 over p when p is 2. So after that, we will take LCM of 1 and 2. Then we got the 2. So matching the denominator of the first fraction with the LCM, here is 1 and here is 2. So it is not going to be similar. So we will multiply 2 with denominator as well as numerator. So 2 ones are 2 we are getting. Then minus this 2 and this 2 is similar. Then we will write their numerator as it is. After that, we will write 2 minus 1, that is equal to 1. After that, we will just going to, there are two conditions. You can cross multiply it with 2 ones are 2 and q ones are q. Also you can take the reciprocal of both fraction. In both of the cases you are getting q is equal to 2 centimeter. Now here look at that, q is in positive. So the nature of the image is real. Because if the q is in positive, then nature of the image will be real. After that, to find the magnification, we will use a formula m is equal to q upon p. Here we find out q is 2 and p is already in 2. So we will cancel it. Then 2 ones are 10, 2 ones are 2, 2 ones are 2. Then it is equal to 1. And if the magnification is 1, then we can say it is same in size. Now, the next numerical is also related with the previous one. We can say uh, the distance between an object and a concave lens is 18 centimeter. The focal length of the lens is 6 centimeter. So here we have to determine the nature, position and magnification by using the lens formula. So in given, we can say that object distance is equal to P, that is equal to 18 centimeter. Now the next one, focal length is equal to F, that is equal to 6 centimeter. And in required, first we have to find the image distance is equal to Q. Second one is the nature of image. And the third one is the magnification M. Now, for finding the Q, we will use the lens formula, that is 1 over F is equal to 1 over P plus 1 over Q. Now here, one thing is more important. We just have to be observed that, okay, what is the nature of the lens? If the nature of lens, we can say if the lens is uh, convex, then its focal length will be positive. While if the uh, lens is concave, then its focal length will be in negative. So here, observe that we are using F is negative. Why? Because lens is concave. After that, to find the value of 1 over Q, we will shift 1 over P on the other side. So it will come in negative. So we can say 1 over Q is equal to 1 over minus F minus 1 over P. Then computing their value, we get the 1 over Q is equal to minus 1 upon 6 minus 1 upon 18, because focal length is 6 and P is 18. Now, we can say that 1 over Q is equal to minus 3. From where? We are getting the 3. Here, this 6 is not matching with the LCM. So that's why we will multiply 6 with 3 to get the 18. So 6, 3 is 18, and here 1, 3 is 3. So we got minus 3 minus 1. Here 18 is similar with the 18. So we will remain 1 as it is. After that, we will add minus 3 with minus 1. So we get minus 4 because both are is in negative. So according to mathematics, minus minus plus. So we are adding 3 and 1, 4, but we will write minus sign because both having the minus sign. After that, to find the value of Q, we will take the reciprocal. So 1 over Q will become Q, and minus 4 upon 18 will become the minus 18 upon 4. After that, we will divide 18 with 18 will divide with 4. So we are getting Q is equal to minus 4.5 centimeter. Q is equal to minus 4.5 centimeter. So keep in your mind here Q is in negative. So what will be happen? Its nature will be, its nature will be virtual, mean the nature of image will be virtual. Why? Because Q is in negative. After that, we are going to find the magnification. So magnification formula is M is equal to Q upon P. M is equal to Q upon P. Here the value of Q we find, that is 4.5, while P, the value of P was 18. So we will divide 4.5 with 18, then we will get M is equal to 0.25. 5. Now I hope so, student, you will understand. After that, home task. So solve all numerical in your register. Now, thank you so much, student, for your cooperation and for your concentration. Thank you so much, boys. And